all to the lecture series of Detailed Electronics KV039/049. I am Dr. Kishanu Kundu and we are in lecture number 11, and in this session we are going to discuss about multiplexers. Multiplexers are very common example of a combination circuit, and it is very useful in designing many circuits. So, let us discuss the concept of multiplexers and demultiplexers. So, in today's lecture we will be going to discuss about multiplexers, how to design and implement the multiplexers, and lastly we will discuss about demultiplexers. Okay. So, first is multiplexer. What is multiplexer? Multiplexer is a combination circuit that has maximum of 2 to the power n data bits, 2 to the power n data bits data inputs, and in that n are the selection lines and one single output, means many input line can be channelized into a single output. Okay. So, that is the multiplexer. On these data inputs will be connected to the output based on the values of the selected line. So, select line having a very important part in this, the select lines only select that output will be depending on which input combination. So, it is the work of select line to choose the input combination, so that output will be depending on that input combination. Okay. So, the n is the selection lines, 2 to the power n possible combination of zeros and ones. Already this is the formula for binary operation. If n is there, the 2 to the power n number of combination will be there. So, each combination will select only one data input, and multiplexer is also called a mux. So, all are in caps, MUX in caps. So, multiplexer in the some multiple variations, 2:1 multiplexer, 4:1 multiplexer, 16:1 multiplexer, and 32:1 multiplexer. So, in every case you can see the output is 1, means see this is 2:1, it can be written as 2 cross 1 mux, it can be written as like this 2 cross 1. So, we have already told that 2 to the power n data input. So, it will be in 2 to the power n into 1 cross 1 format. So, here n is 0, n is not 0, this is 1. If it is 0 means 2 to the power 0 means 1. So, here n is 1. So, then it will be 2 cross 1. So, for this the number of select lines will be 1. Okay. For 4:1. So, 4:2 means 2 to the power 2 cross 1 mux. So, this is the value of select lines. So, now select lines will be 2. For 16 cross 1, so it will be 2 to the power 4 cross 1. So, this is the value of n, and so now number of select lines for this is 4, and lastly 2 to the power 5 cross 1. So, here the number of selection line will be 5. Like that we are designing the multiplexer. So, now we will discuss in detail about 4 is cross 1 multiplexer. If we discuss any of the variant, it will be easy for you to understand the concept. So, first of all this is 4 cross 1, means you can see 4 input lines and 1 output. Okay. So, now if we write like in the format of this to the power n cross 1. So, here it will be 2 to the power 2 cross 1. So, value of n is 2, value of n is 2. So, means n is nothing but the select lines. So, 2 select lines. So, select lines will be termed as S1 and S0. Is it clear to you? And 4 input lines. So, if 4 inputs, then 0, 1, 2 and 3. 4 inputs 0, 1, 2 and 3, 2 select lines S1 and S0, and only one output Y. Output is termed as only one output Y. So, here now we are going to design the multiplexer. It is clear to you, all of you, this thing, 4 input lines, 1 output line and 2 select lines, and here it is written as the one of these data inputs will be connected to the output based on the values of selection line. This line is very important. How it is working? Let us check. See, this is S1 S0. So, we know if 2 variable, then how many combinations are there? 4. So, S1 S0 can be written like this 0 0 0 1 1 0 1 1, 4 combinations. So, in decimal this is 0, this is 1, this is 2 and this is 3. Okay. So, if we are putting S1 S0 at 0 0 means the it is nothing but decimal 0, input 0, then the output will be connected to this I naught input. Okay. So, this is the actual meaning of this line, that one of these data inputs will be connected to the output based on the values of selection line. So, this is the actual concept. So, now if we put S1 S0 at 1 0, this one 1 0. So, 1 0 is nothing but 2 in decimal. So, now for 1 0, which one will be connected? For 1 0, the output will be coming with this one. See, so the output will be coming to from this input. So, it is the work of select lines to select the proper input, and that input will be channelized through the output line. This is actually the concept of mux. Okay. So, now the same thing will be going to design. Okay. So, whatever I have written like this. So, S1 and S0, and this is the output y. So, 2 variable 0 0 0 0 0 1 1 0 and 1 1, 4 combination. Okay. So, you can see from the previous diagram, if the value of S1 S0 is 0 0, the output was for 0. So, y will be for I 0, like that we will write here y will be for I 0. Next, for 0 1, the output will be for I 1. So, we will write here I 1. Similarly, for 1 0, the output will be depending on input I 2, and for 1 1, the output will be depending on I 3. I think this truth table is clear to you. Now, we will write the expression. So, the ultimate output will be y will be, this is nothing but S1 bar S0 bar I naught plus S1 bar S0 I 1 plus S1 S0 bar I 2 and then S1 S0 I 3. You can check this S1 bar S0 bar I naught plus S1 bar S0 I 1 plus S1 S0 bar I 2 and lastly S1 S0 I 3. Okay. So, now this thing will be designing into the circuit diagram. So, this equation we have to implement using the logic gates. So, this will be the diagram, you can check it. This is nothing but S1 and S0. So, here we have gotten one inverter. So, this is the S1 bar and S0 bar. So, first is nothing but the first AND gate 1, 2, 3 and 4. So, this is nothing but this output of this will be S1 bar S0 bar I naught. The second output will be S1 bar, see it is coming from S1 bar this one, and S1 bar S0, this is coming from S0, then I1. Okay. And third one is S1 S0 bar I2 and fourth one is S1 S0 and I3, and all are coming together to a OR gate. This is OR gate. So, the output y will be summation of all this. Already you have discussed, this is the expression. So, the OR gate of OR operation of all 4 AND gates will be the final design. So, this is the design of 4 cross 1 multiplexer. Now, sometime they can ask you the implementation of higher order multiplexer using lower order multiplexer. So, already we have discussed the multiplexer 4 cross 1. So, in 4 cross 1 the number of in 4 cross 1 the number of inputs are 4, 4 is the number of inputs and 2 select lines, 2 select lines. So, now we have to implement 8 cross 1 multiplexer. So, for 8 cross 1 multiplexer the number of inputs will be 8 and select line will be, so 8 is nothing but 2 to the power cube. So, 3. So, select line will be 3 select lines. So, using this we have to implement this, but in 4 cross 1 only 2 select lines are there. So, we will just take 2 4 cross 1 multiplexer and 1 2 cross 1 multiplexer to implement this. So, how we can going to do this? See, this is multiplexer number 1 and this is multiplexer number 2, 4 cross 1 multiplexer 1 and 2. So, we do not know that 4 cross 1 we are having 4 input combinations. So, this is I naught, I 1, I 2, I 3 and here this is nothing but I 4, I 5, I 6, I 7, because total we have to make 8 input lines I naught to I 7, but here these 4 inputs actually what they are 0, 1, 2 and 3, they are also 0, 1, 2 and 3, got it. Now, we are having 2 select lines for 4 cross 1 multiplexer. So, S 1 or S naught we are joined like this and these 2 outputs are coming to the 2 cross 1 multiplexer, because here 2 inputs 0 and 1 and it is having one single select line. So, it will be termed as S 2. So, this combination is also satisfied, this combination is also satisfied, this combination is also satisfied, this 3 select lines, this 3 select lines problem is also satisfied. So, we are having now 3 combination S 2, S 1 and S naught, 3 select line S 2, S 1 and S naught. So, now suppose I have to check output for combination 1 1 0. Let us check this example, very important. We are going to check output for this select line combination 1 1 0. So, 1 1 0 is nothing but 6 in decimal. So, it will be should be connected to I 6. So, let us check how it is coming. So, now S 1 is 1, sorry S 2 is 1, S 1 is 1 and S 0 is 0. So, 1 0. So, 1 0 means 2. So, the output will be connected to this one, output will be connected to this for multiplexer 2 and for multiplexer 1 the output will be connected to this for this. Okay. So, this is nothing but I 6 and this is nothing but I 2, sorry this is nothing but I 2, first one is I 6 and this is nothing but I 2. So, now 2 cross 1 multiplexer 2 there 0 and 1. So, S 2 is 1. So, the output will be connected to the I 2 is I 6 is coming as, sorry this is 0 and this is 1, extremely sorry, here for 2 cross 1 we are having this is 0 and this is 1, because we are calculating from downwards 0 1 2 3. So, it will be 0 and 1. So, S 2 is 1. So, the output will be connected for this. So, now I y is equal to for I 6. Okay. So, you can check it that input combination, the select line combination 1 1 0 with this the output is for I 6. So, here the 4 cross 1 multiplexer can be designed using 4 cross 1 multiplexer. Okay. Next, the same type of question 8 cross 1 multiplexer can be implemented using smaller multiplexer size 2 cross 1. So, 2 cross 1 having only 1 select lines and 2 inputs. So, we have to take 1 2 3 4 5 6 7, 7 2 cross 1 multiplexer is needed to implement a 8 cross 1 multiplexer, because in input size we have to take 8 input lines. So, see we are having I 0, I 1, I 2, I 3, I 4, I 5, I 6, I 7. Okay. So, this is nothing but 0 1, 0 1, 0 1 and 0 1. Okay. And here also we are having the output as 5th and 6th, that is also as 0 1 0 1 and this is 0 and 1. So, now 8 cross 1 multiplexer 3 select lines. So, this for this 3 select lines we have implement this is as S2, this is S1 and this is S0. This is all connected to S0 because all are same. So, here S2 S1 S0. So, similarly if we like the previous example S2 S1 S0, if we have to implement 1 1 0. So, now S2 is 1, S1 is 1 and S0 is 0. So, let us quickly check for 0 all this will be connected, this one, this one, this one and this one, means this will be coming for I0, this is I2, this is I4 and this is I6. Okay. I0, I2, I4 and I6. Now, S1 is 1. So, S1 will be connected for this one and S for this will be connected to this. So, this will be as output will be for I2 and this will be for I6. Now, S2 is 1. So, the output will be for I6. So, see the connection is like that. So, 110 is nothing but 6 in decimal. So, we have implemented a 8 cross 1 multiplexer using 2 cross 1 multiplexer. I think it is clear to all of you. Now, designing of multiplexer. So, first of all we have to check for designing that here 3 variables are there A, B, C. So, for 3 variable maximum combination is 8, right, 2 to the power 3 means 8 combination. So, here it is 7. So, we have to use the first of all we have to check the size of marks, we have to check the size of marks, right. So, size of marks, for that we have to follow the formula that number of select lines will be number of variables, This is very important formula, number of select lines will be number of variables. So, here number of variable is 3. So, number of select line will be 3, very easy. So, we are having S2, S1 and S0. So, S2, S1 means we have having 8 cross 1 multiplexer. So, see here we have having minimum is 1, 2, 3 and 6 and 7. So, the result will be for 1, 2, 3, 6 and 7. These are connected to logic 1. Okay. This will be connected as a logic 1 and those who are not present there like 0, 4, 5, 0, 4, 5. So, these will be connected to as logic 0, 0, 4, 5, 0, 4 and 5. This will be connected to as logic 0 or ground, you can say that. So, this is the implementation of design implementation of multiplexer of FABC summation small m 1, 2, 3, 6, 7. This is very easy because already we have clear that what is the size and according to that we will be connecting as logic 0 and logic 1. But the problem comes where the here number of variables is A, B, C, D means number of variables is 4. So, 4 select lines, 4 select lines means the actual size of mask is to the power 4 cross 1 means 16 cross 1 multiplexer is actual size, but here you have to implement it using 8 cross 1 marks means bigger size marks you have to implement using small size marks, right. So, in that type of problems we have to do some modifications. See here the maximum number is 15. So, then also you can understand that is used can be implemented by 16 cross 1 marks, but here we are having 8 cross 1 marks means 8 cross 1 marks means 3 select lines, right. So, 3 select lines we are putting like this, 3 select lines we can put like A, this is B, C, D, suppose we are having this is B, C, D. So, these 3 are select lines and this is one input lines. Okay. So, now we will make a for table. So, here we will put this 3 select line like this and this is A. So, we are having 3 variables. Now, how many combinations? 8. So, the numbering is 0 0 0 0 0 1 0 1 0 0 1 1 1 0 0 1 0 1 1 1 0 and triple 1. Okay. Then this is 0 and 1, value of A is 0 and 1. Okay. Here not Gray code format, it is not K map. One more thing I am telling that it is normal combination 0 to 7. Okay. So, now we will put the numbering, this is 0 1 2 3 4 5 6 7, then this is 8 9 10 11 12 13 14 15. If you are having any confusion about the numbering, see this is 1 and triple 0. So, 1 triple 0 is 8, then 1 0 0 1, this is 9, 1 0 1 0, this is 10, 1 0 1 1, this is 11, 1 1 0 0 12, like that. Okay. So, now why you are doing this format? So, we have to put these values means maximum output is 1 for these values. So, we will put this 1, for 2 it is 1, for 6 it is 1, for 7 it is 1, for 8 it is 1, for 12 it is 1, for 14 it is 1 and for 15 it is 1. Okay. So, 1 1 1, then it is 1 4 ones. So, now if we check here, so this is the most important part of this type of problem. See, here only in this column we are having this one, having this column in 1 like this, here 2 ones and here like this. So, now we will put that this is nothing but A bar and this is A. So, we will like this as A, because this is A B C D and this one is A bar B C D. So, common only we are having for A, right. This is column is for B C D. So, the value will be A. Now, here it will be A bar, because it is the row of A bar, we are having 1 in the row of A bar. Here also it will be A bar. Now, no ones are there, means it will be 0, nothing is there. Now, here again it will be A, again this is nothing, no ones are there, this will be 0, and in this column both row are having 1. So, 1 for A and 1 for A bar. We know A plus A bar is 1. If both the rows are having 1, then we will be like putting as 1. Okay. Here also we will be putting as 1. So, finally, we have got the values. So, now A will be connected to 0, 1, 2, 3, 4, 5, 6 and 7. So, 0 A and 0 3 and 0 5. So, 0 3 and 5 will be connected to as 1, right. Okay. Sorry, no, this is for 3 and 5, where for 3 and 5 we are having 0. So, logic 0 we are putting like this, here 0 1 2 3 4 5 6 7. So, first of all we will put the 3 and 5 as logic 0, 3 and 5 are logic 0. Now, A is for 0 and 4, 0 and 4 are having A, 0 and 4 having A. So, we will put as 0 and 4 as A. Then A bar is 1, 2 and 1 and 2, 1 and 2 is A, see A bar. So, here we can put a and will be 1 and 2. Okay. Now, 6 and 7 is connected to logic 1, 6 and 7 is connected to logic 1. So, this is the final design. Okay. We have implemented the and these all values are A. Okay. So, A B C D 4 variables can be designed like that, B C D will be select lines and A will be input line. So, the 16 cross 1 size of marks can be implemented using a 8 cross 1 marks. Okay. Another problem, the same thing you can design using 4 cross 1 multiplexer, you can do it by your own. Okay. Here nothing but the thing is that 4 variable A, B, C, D. So, it will be like that A, B and C, D, and the combination will be no K map combination. This will be 0 0 0 1 1 0 and 1 1, 0 0 0 1 1 0 and 1 1. So, numbering will be 0 1 2 3 4 5 6 7 8 9 10 11 12 13 14 and 15, like that you have to put 1. So, we will be putting as 1 2 6 7 8 12 14 and 15. So, like that you have to put the one. I am doing here, see, this is don't we are having both 1. So, it will be coming as A B bar plus A B. So, this will be coming as A B bar plus A B, like that you have to look here only 1, here this 3. So, it will be added as like that same before, you have to do by your own. Okay. And this is demultiplexer. Demultiplexer is just opposite to multiplexer. Perform the reverse operation of a multiplexer. It receives one input and distribute it over the several outputs. It had only one input 2 to the power 8 outputs and n select lines. Same concept of select lines will be there, and at a time only one output line is selected by the select lines and the input is transmitted to the selected output lines. So, that will be 2 cross 1 multiplexer, it will be 1 cross 2 demultiplexer. It will be written as demux, like that, demux. Okay. So, just reverse 4 cross 1 multiplexer, 1 cross 4 demultiplexer, like that. So, this is shortly I am telling, this is 4 cross 1 demultiplexer. So, here n is equal to number of 1 cross 2 to the power n. So, 1 cross 2 to the power 2. So, n is equal to 2. So, n select lines and one input and 4 output, 1 cross 4. So, 4 output, like that. Okay. So, the design is like that. So, 4 variables 0 0 0 1 1 0 1 1. So, 0 0 for this will be connected as output will be for this, for 0 0 0 1 this, 1 0 for this, and remaining will be 0. Remaining will be 0. So, this is for select line and this is for outputs. So, y naught will be for this one, S 1 bar, S naught bar and I, because input is I na, we are having input as I. So, input combination will be for I. Then y 1 will be S 1 bar S naught I, y 2 will be S 1 bar S 1 S naught bar I, and y 3 will be S 1 S naught I. Okay. So, this is the thing, and this will be like that. We can design it using logic gates. Similarly, how do we have designed this 4 cross 1 multiplexer like this. So, it will be we can design 1 cross 1 4 demultiplexer, and